Namaskar friends, I Poonam Dogra on behalf of Wechitra Enterprises welcome you all and hope you all are doing very well. Friends, you might have heard power factor or might someone have given you an advice that you should increase your power factor in order to reduce your electricity bill. And friends, this is a very important topic because this factor can increase your electricity bill or can decrease the amount you are paying on electricity. So in this video we are going to learn about power factor, that what is power factor, one. Second, what are the benefits of a higher power factor, what are the values of power factor we should maintain. Now, before discussing power factor, let us discuss some of the points which are related with power factor. And these are current, voltage, and load. So, what is a current? A current is the rate of flow of electrons. So, current flows from higher potential to lower potential always. So in this picture, you can see an easy depiction of current and voltage. Current is the flow of electrons through a conductor. Conductor can be your wire, your cable. And resistance is the property of the conductor to resist that flow of current. Fine. And voltage is the force which make current to flow in a conductor. So voltage is the force which makes current to flow, which pushes current to flow in a conductor, and resistance is the property of the conductor to resist it, and current is the flow of electrons. Now coming to types of load. So any device that consumes electric power is your load. These can be your fan, AC, motors, oven, etc., which consumes electric power. Electric appliance that consumes electric power is electric load. So mainly electrical loads are of three types. First one is resistive load, resistance. Second, inductive load. Third one is capacitive load. So talking about resistive load, here you can see its circuit, and this is the symbol for resistive load. Resistive load are mainly which are used for heating, like oven, heaters. These loads are resistive load, and in these loads, your voltage and current, this red, the waveform shown with red color is voltage and with blue one is current. So your voltage and current waveform will not have any phase difference. So they will start from the same point and will end at the same point. This is a resistive load, and you can check this vector diagram. Voltage and current are in the same phase. Now coming to inductive load. Inductance is a property of a coil which opposes the change in current. And most of the loads which have coils in them, coils like we have in motors, transformer, in fan, we have a motor, and compressor, and washing machine. All these load have inductance. These are inductive load. And you can see here circuit diagram of it. And this is the symbol for inductance. So here you can see there is a phase gap, a lag between the voltage and current. This red one is voltage again, and this blue line is of current. And here you have a 90-degree lag. Current is lagging behind the voltage. And This is the vector diagram. Here, this is voltage, and your current is lagging behind it by 90 degree. And third one is capacitive load, capacitance. This is the symbol of capacitance, and capacitance is the property to store energy. So load, like you have a capacitance in your fan, or you have uh, capacitor bank for improving your power factor. These are capacitive. In capacitive load, your current, you can see here in this waveform, current will lead the voltage. So here is a 90-degree lead of current. And in vector diagram, you can see here again, this is your voltage, and your current is leading by 90 degree. So this is all about the types of load. Now coming to power triangle diagram, and this is very important because in this slide you will come to know what is power factor, and I want a little more attention from your side for this slide. So as we have gone through what is current, what is voltage, and what is the difference, phase difference between them according to different types of load. So as it is leading for capacitive load and lagging for inductive load. So in a factory or in a commercial building or any your property, loads can be of different type. So it can be resistive, it can be capacitive, inductive, or mix of every type of load. So in that case, we have a phase difference of phi between current and voltage. So this is phi. Here you can see this is phi, which is the phase difference between current and voltage. Now in this power triangle, as we know that power equals to VI. So apparent power is P equals to VI, VA. This is apparent power. But in reality, we have a phase difference between them. So the real power is P equals to VI cos phi. This is our real power, which is coming to our load, we can say, or to our uh, premises. This is the real power. S is apparent power, VI. And Q is reactive power, VI sine phi. Again, phi is the phase angle between voltage and current. And this is again formula for the triangle. So this is not very much needed. Here you just remember that apparent power is VI, but the real power is less than apparent power due to this phase difference, which is VI cos phi. And this one is reactive power. This power remains in the circuit and moves just back and forth in the circuit. So this is a kind of losses only. And this factor cos phi is power factor. This factor is power factor. So formula becomes P equals to VI cos phi, VI power factor. Now I'll try to make it little easy with a relatable example. So assume you have a glass of beer, and in that you're paying for the whole beer, for whole glass of beer, in which this much of real beer you have, which is real power, and this foam above that is your reactive power. Fine. And this whole glass of beer is your apparent power kVA. So this is the diagram. Apparent power again. This is apparent power for which you are paying, and this is your real power. VI cos phi. Okay, this is your real power. But if your cost factor decreases, you can see if your phi decreases, then your real power will decrease. And again, you will pay for the whole apparent power, but you'll get less or less beer. So for this only, you are advised to increase your cos phi, your power factor. Here you can see formula for power factor, that is real power divided by apparent power. So as much as your power factor is near to unity, near to 1, then your power will be good. Your power will be more, you'll pay for more power. So your cos phi should be near to 1. So that's why we say to improve your power factor so that you can pay for the whole power, for the maximum power you are getting from the distribution company. Now again we'll summarize it. Apparent power equals to VI. Real power is P equals to VI cos phi, which is in kilowatt. Power factor equals to real power by apparent power. Again, we can write it as VI cos phi by VI. So cos phi is your power factor. Okay. Now phi is the phase angle between your current and voltage. We have learned this in our previous slides. And as the phi increases, cos phi decreases. So this is according to trigonometry. For 0 angle, your cos will be maximum 1. For 90-degree angle, your 90 will be 0. So as your angle decreases, your cos phi increases, your power factor increases. So for this reason only, we use capacitor bank, sorry, capacitor bank, because we have seen in our previous slide that for inductive load, your current is lagging behind the voltage, and in factories maximum we have inductive load. So if it is lagging, you need to make it little leading one to decrease it. So to make it a leading one, we need capacitors, and this capacitor and inductive load will cancel out the effect of each other. That's why the phase angle will decreases and our cos factor will increases. So this is the reason why we use capacitor, because capacitive load is a leading power factor generating load, and inductive load is lagging. So power factor value should be power factor's value will be from 0 to 1, and it should be as much as near to 1. So now according to government's norm in India, your power factors should be greater than 0.95. So less than that, you will be penalized. And for maintaining above 0.95, you will be given rebate on your electricity bill. So this is how you can uh, increase your power factor by using Capstra Bank. And in this video, we have seen why we need to increase our power factor and what are the benefits of increasing your power factor. As much as you increase your power factor nearer to 1, you will get the maximum power from the discom, and you will also be given a rebate on your electricity bill. And in our next videos, we'll see that how this rebate and penalty is shown in your bill. You can check your electricity bill for rebate and penalty in your power factor value. So this is it from my side. See you soon in the next video. Thank you. Thank you for watching.